There we go. Afternoon, everyone. Thanks for joining us. Just at about 3:30 Eastern. Okay, Julie, can you pop the slides up, or is it Simone that's running?
There we go. Can you see them?
I can.
Excellent.
So we're going to get started. Hi, everybody. My name is Bob O'Sullivan. I'm the associate publisher for Test Prep at McGraw-Hill. Welcome to our 5 Steps webinar for AP Computer Science Principles. This is our second one of the year. We're about, believe it or not, 6, 7 or so weeks out from test date. So let's just give everyone maybe a couple more seconds to file in. And we can get started. Before we get started, can you click the next slide for me, please, Julie? A couple housekeeping matters right up front. Just as a reminder, we're welcoming both AP teachers and students to this session, but it is primarily a student-focused review session. Any of you that are on the line now that are able to join us live, that's great. You can feel free to share the link with other students in your class or fellow teachers or educators that you know. That's going to be available for you starting tomorrow. The details will be coming later. There's not so many people on the line today, so don't worry so much. If you have a question, I would suggest you ask it either through the chat or the Q&A feature. It's only when we have a real lot of people that becomes an issue. A reminder that none of you, the students on the line, will be able to see one another. So you have to worry about that. You should be able to hear both Julie and myself, and that should be fine. No student data is being collected for those teachers out there that have any concerns. Anyone on the line that has not signed up that's joining as a student, we will not be collecting any data. A reminder that it's interactive. We're going to have some polling. We're going to go through some questions. Please do feel free to participate. It makes it a lot more fun for everybody and a lot more interactive. So speak up, answer the questions, participate as much as you'd like. And a reminder again, the session's being recorded. This will be available in full tomorrow. That's the bit.ly if you want to take the URL, if you want to take a quick picture of that with your phone. I'll give it a few seconds. We'll show it to you again toward the end of the presentation. But everything we go through today, all this great information that Julie is going to share with you will be available to share with all your friends and fellow students, fellow educators, and so on. And that's it. So with that, I'm going to hand it over to Julie Sway. Julie, over to you.
Okay, so hello, everyone. Let's get going with AP Computer Science Principles. So we're going to here's a brief look at our agenda today. Very little bit of information about me, but mostly information coming from the College Board Chief Reader Notes. These are very valuable to teachers so that we can find out where our students were weaker in the prior year so we can improve our teaching the following year. We're going to review some essential topics and then have some practice questions. And then Bob's going to do a bench prep course summary so we get a little look at that. So just a little bit about me. I have taught this course since its beginning, and even actually the year before it was an official AP computer science course. That helped us get familiar with the curriculum and get a head start on things. I've been a reader for the course since its first year as well. I used to do software development for Coca-Cola in Atlanta and Vienna, Austria. Sehr gut. And then Southwest Airlines, both excellent companies to work for, by the way, for future reference. And then this course is newer than the AP Computer Science A course. It's been around since 2016, and it covers a wide breadth of topics, but it doesn't go very deep. So there's a lot of information to cover, but we don't get too much into the nitty-gritty. So let's get started. All right, so every year the chief reader provides these notes to us. Some of the areas with the biggest downfalls where students missed most of the points and just crucial things to know. And we're going to be talking about the create performance task here because the multiple choice part of the exam is graded automatically, of course. So this is the section that the AP readers who are faculty who actually teach the course or college and university faculty. All right, so as you know, by the way, Tom Cortina is the chief reader right now. That rotates like every 3 or 4 years. And he is a professor at Carnegie Mellon University in their computer science department. So these are his notes from last year, which are very helpful to us. All right, so as you know, you have 3 things that you have to submit to the College Board. And when you log into the digital portfolio, you'll see a category for each. WR stands for the written response to the prompts. And this is in lieu of like the free response questions that other AP exams have. You have to have a video showing all or part of your code working. Now, if you have part of your code that's not working, don't show that in the video, all right? But make sure the part you do show is what you write about. That's one of the things that we as AP readers have to look for. And then you need to provide your program code in a PDF document. And my request to you is please make sure it is visible. We use that as a document sometimes when we can't view things in your written responses where you have to include snippets of code. We'll go look up in the regular document. And if we can't view either one, then we can't assume anything and we can't award you the point if we can't verify. So make sure it is viewable for eyes that are older than yours, like mine, okay? All right, so here is the first prompt. Here are the questions up above. So these will probably look pretty familiar to you if you are far enough along in your semester or year program to have started on this. All right, so one of the areas that students really struggle with is distinguishing between the purpose of a program and its functionality. So I put the definition of just purpose up here. It's the reason why something's done. So we do a program to provide entertainment, to learn something new, to find a restaurant, to get a book or a movie recommendation, something like that. That's why we pick it up. And then the functionality is talking about, well, how does it do that? All right. It might create a single player game. It might display a list of facts you could flip through and then quiz yourself. It may prompt you for questions like, what kind of food are you interested in? How far do you want to go to get it? Or can you have it delivered? That kind of thing, and then provide a response. So make sure you understand the difference between why and how. All right, you also have to describe the input and output that is demonstrated in the video. Okay, don't miss that part. You got to make sure you're writing about what you displayed and shared. And we do watch the videos for sure. Make sure your video is also legible, by the way. Sometimes when we have to compress those, they get very grainy and not very viewable. So take a look at it if you have to compress it before you submit it. All right, so here's a little chart over on the right that kind of describes this. All right, you're going to show input to your program, whether you're typing in from the keyboard or you might be pressing keys or swiping on a screen for a tablet or a phone. And then your program does something to that input, and then it produces some kind of output. And you got to make sure you show that. All right. Moving on to section 3B. This is where we're going to start talking about data abstraction and the managing complexity in your program. All right, the first couple of things you have to do are screenshots. All right, so here's where I'm talking. Make sure your screenshots are viewable. And I would not even do like a whole screen screenshot. Take a screen snippet. Both PCs and Macs have a little piece of built-in software where you can drag and take just a small snippet of a piece of code or anything on your screen, but in this case code, and plop it into your written response. All right. So you're going to show how elements are stored in your list and then how the list is used to meet the program's purpose. So even if the list in your program is initially empty, don't show that. You need to, your code snippet needs to show where data is loaded into the list. Whether you're prompting somebody for information that you're going to use later, that's where you need to show the code. All right. And then where is it used? All right. You may then pull an element out of the list or go use it in a loop to search the list for a particular item. Or you may pull something at random from the list, but show where that snippet of code is, all right? So then you're going to start writing about these two snippets, all right? Give the name of the list. That's an easy one, all right? Make sure it matches exactly, all right? But only include one list, all right? Zoom in. If you have multiple lists, just zoom in and just give the snippet up here of the one that you're going to talk about. Because if you list more than one list, if you provide more than one, the readers are only allowed to look at the very first one. And that may not be the best representation in your program, and it may not be the one that you necessarily have snippets of here. So if you show multiple lists, please make sure that you are talking about the right one and it's the first one. Okay, so then you have to describe what the data in your list represent. It may represent temperature values, a list of books, a list of movies, a list of restaurants, a list of stats, whatever it happens to be for yours, describe what it is. All right, that one's pretty straightforward. Now this last item, number 5 here, explain how the list manages complexity in your program. This is the one that catches everybody, because I'll tell you, there are only 6 points that you earn for this create performance task, and it counts for 30% of your score. But you have to get all sections of these. They have multiple sections in each question. You have to get all of those to be able to earn the entire point. There's no half points or quarter points or anything like that. So really pay attention to this number 5 right here. How does the list manage complexity in your program? Sometimes I would see some where students described, hey, that's a pretty good description and definition of a list, but they didn't go on and explain how it manages complexity in their particular program. So also, don't just say, well, my program couldn't run without a list. Most of the time, programs can run without lists, and they require, additional variables to hold values and additional processing, but it could run. So don't say that. We saw that a lot, and it's just inaccurate. So you won't earn the point in that case. All right. So now we are on to procedural abstraction. All right. So once again, screenshots. All right, you have to screenshot every procedure that you wrote. It has to be a student-developed procedure. Some programming languages, such as JavaScript, which is a language a lot of students will use for this, have on events, and those are built in. It's not something that a student created. Now, you can have a procedure you write that includes an on event, but it has to have other processing. You just can't create a procedure and then have one statement inside of it that's the on event. All right, so make sure it's something you wrote, not just something that you're using. And so have a screenshot of that. And then you need a screenshot or a screen snippet, I'll say, of a call to the procedure. Now remember, with procedures, they just sit in your code, waiting to be called, waiting to be put into the game. And that's what you need to have, is the call in your procedure. You're going to describe then what the procedure does and how it contributes to the program's functionality. All right, also with that, you're going to talk about how the algorithm in the procedure works. So the chief reader made a point to say that this is a section where students who spoke about this at a higher level did a better job connecting it to the overall functionality. All right, so that's up in step 3 right here. So don't describe line by line what you did. I defined my variables. Then here is where I started a if condition. This is where I started a loop. Don't describe it like that. Maybe describe like, okay, I asked the user for input on what type of food they wanted. I asked how far they wanted to travel to get it. I asked things like that. And then I use those variables to select a random selection from a list of restaurants that met that criteria, and then produce that output. So that's the kind of thing you're going to want to describe. Make sure in your procedure that you have at least one parameter, and it has to be an explicit parameter. All right, so when you describe it, and we'll see an example here of how the College Board looks at those in a moment, but make sure that you have that explicit parameter versus one you're going to pass implicitly through the program code. All right, use the parameter in your procedures code. we've seen quite a few where a parameter was listed there, but then it was never mentioned again or used in the program anywhere. All right, so that's trying to meet the criteria, but doesn't quite meet it. And that's, definitely something we have to look for. If you have multiple procedures listed, we can only look at the first one to consider it for the score. All right, it is okay if that procedure calls another procedure, which may then call another procedure. That's one of the great ways you can use procedures in your code. But we are only going to look at the first one as we evaluate the writing for it. And then the last step is make sure you describe how the procedure works in enough detail that someone could recreate it. So this is the area where you're going to go a little more step by step and describe at a pseudocode type level. All right, so part code, maybe part English or entirely English, how your code works. I initialized variables. I then prompted the user for input to give me the temperatures or the rain amount, that kind of thing. And so the readers are kind of mentally going through that saying, oh yes, I could write this procedure in that enough detail to recreate it. All right, on to the last section, 3D. All right, so we're still on procedural abstraction here. All right, so this is where you're going to show the calls to the procedure you wrote about. All right, so you need to have at least 2 calls. All right, and the code has to execute as a result of these arguments used. Now remember, arguments are what send values to the parameters in your procedure. So you're going to describe those calls and then describe the conditions tested by each call. And an if statement is a perfectly fine and a very easy way to do that, because if your condition is true, you're going to execute this section of code. If the condition is false, you're going to come down and execute this section of code. So that's a very easy way to show the conditions tested by each call. And your calls need to have the 2 sections executed. You can't have 2 different calls that end up executing the same section of code here. That won't cut it. That won't earn you the point. And then you're going to identify the results of the call. So for example, if we had a temperature value, and if the temperature was greater than 100, then we would execute this call. It might send an alert, turn on the air conditioner, that kind of thing. Or if the temperature was less than 100, then everything down here is fine. We would turn off any alerts that were running and send a good message that everything is back to normal and go that way. So make sure you take care of both sections of code with each of those calls. All right. For the PDF of your code, again, you want it to be visible, and it's okay if it's a little bit small, but as long as when someone zooms in, it doesn't pixelate. That needs to be the case with all of your screen snippets. But with your PDF, some program code, like block-based code in particular, doesn't easily print, and sometimes students are having to take screenshots or cut and paste that way. But a wonderful computer science teacher named Baker Frank created this module, and it's at this link below, and it easily creates a PDF of block-based code. And he made it available to everyone at no charge, so just know that it's there if you need it. So your create performance task is due May 1st at 11:59 p.m. Eastern time. Now, for those of you who may not be located in Eastern time, the College Board site does specifically say Eastern time. So be aware of that, all right? And then 30% of your score is done. Check, don't even think about it anymore. You're done. You can't do anything to change it. Now, on any of these sections that I've talked about, if you realize, oh, I didn't do that, or oh, I could probably do a better job of that, if you have not submitted final, you can still go back and modify your written response, get a better screen snippet if you need to, and submit again, because the readers only see the latest version, the last version that you uploaded to the site, and you can upload multiple versions until you hit submit final. All right, and here's our first check-in. Any questions? All right. And if you're interested, you can give me a thumbs up or some kind of reaction that kind of best represents how you're feeling about your Create project. And I'll bet they're all going to be good, and I'm looking forward to reading some fascinating ones. Every year, they're always interesting. All right, moving on to essential topics. So these are some of the topics that give more students issues than some of the others, and they are, key to doing well on the exam and on the Create project. So these are the topics we're going to go over: procedures, parameters, the return statement, and lists. All right, so I really like this diagram for procedural abstraction because basically it means it's a black box concept. All right, as soon as you finish writing the code and you've tested it adequately, you don't have to worry anymore. Or if you're using a built-in function, you don't even get to see the code. You just know the inputs that are required, and then you know the output to expect. And you don't have to worry anything about what's going on in the inside with the actual code. What's nice, procedures can be reused and called as many times as needed in your program. There isn't a limit. It makes your code shorter because you only put it in there once and then you call it multiple times. You don't have to repeat or duplicate code. So it makes your code shorter, easier to read. And then my favorite, of course, is that you only have to update it or make a correction if you have a typo or something wrong in it. You only have to fix it in one place. Whereas if you had duplicated your code, you'd have to fix it or modify it in multiple places. And then our code is very flexible through the use of these parameters. As long as I give it the right type of parameter or value, send the right argument or value to that parameter, I can use it with multiple ones. If it's expecting numbers, I can send it with any kind of number. If it's expecting a string or a character field, as long as I send it as a character, it will accept any type. So it makes our code very flexible. All right, so here's the diagram. This is what it looks like with the, how the College Board is going to write these in the questions. All right, so we have the keyword procedure, and that's why it's in all caps. And then we have the procedure name, which, if you're the programmer, you get to decide what the procedure name is, but in the questions, you'll see it'll already be there. And then we have any parameters, all right? So the parameters receive values from the arguments when you call the procedure. All right, and then inside the braces here, we have the block of statements that go with the procedure, whatever it's doing to process that data. So here are a couple of calls to this procedure. So notice we call it by its name, and it has to be spelled exactly the same. Notice right here, capital N, and it's because there's a capital N right there and everything else is lowercase. You also have to call it with the correct number of parameters. So this one has 2 right here, so we give it 2 values there, and these get mapped, the first one to the first parameter, the second value to the second parameter. All right, and notice you can call it, I have it here with 2 variables. I have it here with 2 numbers, assuming that this one is looking for 2 numbers. And then I have it as a call here with 1 variable, arg3, and then 1 number. So you can do it with any combination there, and it's acceptable. All right, so one area that people get confused about is the scope. All right, so the scope of parameters means that they are local to the procedure. And I put a little house around it here. Maybe it needs to be a fortress or something, because parameters cannot leave the house, all right? They are trapped. When your program code ends for the procedure, the official term is garbage collected. And basically the code will clean up after itself and free up the memory that that code was using, so it can be used for something else. So that's why the parameters are not available outside of the scope of their code. So sometimes students will see a message and get something about an undefined variable. And they're like, no, I see it right here in my procedure, but it's because they're trying to use that variable name outside of the procedure, and that's why they get the error. And again, here's another example of our call. This procedure is called pet care, and it only takes 1 argument. So there's 1 parameter here, so you have to send it with 1 argument. So here's a variable sending it, and then here are 2 different strings being sent to that particular procedure. All right, now we're talking about the return statement. So it's in all caps because it is a keyword, all right? It immediately exits the procedure. Anywhere it is, if it's at the beginning, if it's the first line of your procedure, nothing else will run. Your procedure will get called and immediately exit and go back to where it was called from. So it sends control back to wherever it was called. So remember with procedures, when you have a call in your program gets paused and it goes and finds the procedure with that name and executes the code in that procedure and then comes back to the next line of code where it was called. All right, so that's where it sends the control back. So you can use this for something like a check. All right, so if, for example, a common use of this is if you could get data that you're dividing and you could end up with dividing a condition where you divide by 0. So as you know, you can't do that. You can't do that in math. You can't do that in computer science. So if you have a value that you're about to divide from, do a check on it. If value equals 0, then return, and you might return back with an error message so somebody knows what's happening. Otherwise, if you try to divide by 0, your program will exit with an abnormal ending right there. And that's what you want to try to prevent that anyway. All right, you can also just hit a return by itself, but you can also return a value. It can be a number, a string, a Boolean, or an expression to evaluate. So here's an example where you are sending back a value. So you may have done a test here where it said, oh, if score 1 is greater than score 2, then hey, the winner is team blue. All right, that's what you would return. Here's an example of an expression that's going to get evaluated first, and then just the single value, the single digit that is the answer to the evaluated, the evaluation here, the string here, the formula, whatever, gets sent back. It gets returned back. Now, one of the key things that a lot of students get confused about is if you plan to use this value that's returned later, you have to capture it in a variable to use it later. You can put it immediately in a display or a print statement if you don't plan to use it later, and that's fine. But if you want to use it for any type of processing or use later, you have to store it in a variable as soon as it's coming back. All right, on to lists. All right, so a little bit of review, hopefully. Lists have elements, and the elements in this list, named pets, are dog, cat, bird, and turtle. You find out the location of each of those elements using its index. And I put the index position under each one here in this little table at the bottom. Now, there are methods that you're responsible for knowing and understanding for use with lists, and we're about to go over those. And then just remember, it's the for each loop that is like best friends with lists. They were made to hang out with each other. They work very well together. All right, so the first method you're responsible for knowing is length. And the format is, length is the keyword. That's why it's in all caps. And then you give it the list name in parentheses. All right, so it just returns an integer, and it's however many elements you have in your list. So this particular one here, length of pets, returns the integer 4. This is really handy because if you have a list of lots and lots of numbers, think of businesses that capture all your screen clicks, what items you clicked on, what items you put in your shopping box, what items you actually returned, what ones you actually bought. That gets to be very long lists. All right, and you can use the length so it will count it for you and you don't have to count it yourself. All right, another list method you're responsible for knowing is append. And all it does is it puts a new element at the very end of the list. So just remember, with your keyword append, it has the word end in it. So that helps you remember that it goes at the end of the list. And here's the format. You give it the list name first, and then the value that you want to add to the end of your list. So here's an example. If I want to add the word fish to the end of my list pets, this is the format that I would put it in, and this is what my list would look like afterwards. All right, we also have insert. Insert's very handy because you don't always want to put a new element at the very end of your list. So this lets you put it anywhere inside your list. I would still use append to put it at the end of the list, although you could use index and put it at the end that way too, or insert and put it at the end. All right, similar format. Insert is your keyword in all caps. Then you give it the list name, the index of the location where you want to put it, and then the value you want to put there. So this example here will insert hamster at index position 3. And the important thing to realize here, because this is what they'll kind of be some of the responses, is they're going to see if you understand that what happens is that hamster gets inserted and all the items to the right of that location move over one. This is what the pseudocode that they use for this programming course or this AP Computer Science Principles course does. With some other programming languages, you have to do that yourself. But for the purposes of these questions, know that if I insert hamster here, the length of my list becomes 6. And then notice that fish moved over to 6, turtle moved over to 5, and bird moved over to 4, and hamster was inserted. Nothing got overwritten.
Julie,
Similar
just
with,
a quick
yes,
reminder, we're at 4 o'clock Eastern, so you're 30 minutes in. Just
perfect.
give me a little time check there.
All right, thank you. All right, remove works very similarly to insert. All right, you give it the list name and then the index position, not the value. I'm saying I want to remove whatever is at index position 4 here, not that I want to remove bird. Okay, similar kind of concept. All right, we remove bird, but then turtle gets moved down and then fish gets moved down. We don't end up with holes in our list here. Okay, so be aware of that. All right, and then we talked about how lists and for each loops work so well together. So it's a great way to iterate through your list. And here's the format, the words for each, and then in are all the keywords. We get to decide the name of our iteration variable item. And then here's our list name. So we're saying like for each pet in pets, for each name in class roster, for each score in the game, that kind of thing. So what students sometimes struggle with is understanding that item takes on each individual value from the list once for each pass through this loop. So for the first iteration, the value of item will be dog. And any processing we do here is related to dog. And then it comes up and says, okay, I'm not done yet. Now item is the value cat. All right, that's the value of our variable, and all processing is done with cat. We go on up, we're not done yet. It picks up the value hamster and does all the processing for that, and on with turtle and on with fish. And after it finishes fish, it says, all right, I'm finished with my list. And so it exits our loop and goes on with the next line of processing, or ends the program if that was the end of it. So just make sure that you understand that item takes on a single value in the list, one for each iteration through the list. All right. Any questions at the moment? And I hope you guys are all feeling good about procedures and parameters and scope and the return statement and lists. All right, let's do some practice questions. So we're going to do this with a poll. So if you would answer through the poll, and then we're going to give you roughly, shorter questions, maybe 30 seconds, maybe a minute for the longer questions if you have to read more. And then we'll go over the answer and explain each one. So here is the first question. There you go. It's popping up right there.
For anyone viewing the recording, you can easily move the poll feature over if it's blocking the question itself. Just a reminder there.
All right. So very good. We've got index out of range. And let's go over and explain that for those who might not have answered that. Let me move this up a little bit. All right, so here's our variable name, fact. And it has this string in it, coding is awesome, which of course it is. And I put it down here in a table because strings, just like our lists, each have an index position. All right, and so we are looking for index position 19 here in the square brackets. And if you look over here, we do not have an index position 19. So that's why we get the error. It does not then pick up the last value of the exclamation mark. It doesn't wrap around to the first again. We just get an error saying, nope, we don't have that position available to us. All right, next question. All right, no guesses yet on that one. So let's definitely talk about this one. All right, so this is the kind of question that I highly recommend you write in your test booklet. You can't take scratch paper in or anything like that, but you can write in your test booklet. And then if you're not sure about one, then you can go back and you don't have to rethink it all in your head, where it's really easy to get off anyway, especially in a test kind of environment. So create a table here. Here's my variable count, and it starts out at value 5. Degrees starts out at 78. And then we're repeating until count is less than 0. So right now, 5 is not less than 0. So we enter our loop. The value AVG for average is just calculating degrees divided by count. And I just wrote those values here with not having to calculate it right now. Then we add 3 to degrees, and then we subtract 1 from count. And then we go back up and we check our loop. All right, 4 is not less than 0. So we enter our loop. We go through the same thing. Here's our average calculation. Add 3, subtract 1 from count, and go back up. We do this a couple more times. Everything's running along just fine. And then, okay, so here we are at count is 1, degrees is 90, and then our average is 90 divided by 1. So we add 3 to our degrees, it's 90, 93, and then we subtract 1 from count, and we have count is 0. So now we come up to our loop, and 0 is not less than 0. So we're still going to enter our loop. All right, so AVG is degrees divided by count. Hey, we talked about this a little bit earlier with our return statement. Just like in math, you can't divide by 0. So this is where you get an error with your runtime error, okay? Everything is running along just fine until it hits that specific condition. So these can be hard to find sometimes, and that's why you need to test your code really well for all possible situations and make sure your program handles them. All right, on to the next one. All right, we better go over this one. Okay, so in this one, we have 3 parameters. We have this string. So in this case, our string is fact, and it's holding coding is awesome once again, because it still is. And then we have the starting position of a slice or a section of the string, and then the length of the slice. I often see questions similar to this in the released exams that have been, released to teachers. All right, so just kind of be aware of these. So we take our example, all right, and then we look for 14, index position 14. So here's our table just like before, and we go for a length of 4. So it takes us up to the word the E in the word some. So we have this string SOME, and then we add a space. That's what's in between the double quotes here. We add a space, and then we concatenate another section of the string, and we start at index position 1, and we go for a length of 3. So we get some space cod, and that's the answer. All
Julie,
right,
I don't mean to cut you off here. Somebody left a question a
Sure.
couple of minutes ago. I don't know how far back this is going, but what's the difference between a logic error and a runtime error?
Okay, so a logic error could run back. Oh, there it is. Okay, so a logic error could be something, these are really hard to find, by the way, because it could be something where instead of doing addition, you did subtraction. So you're probably getting a value and it's running fine, but the values are like off. It's not kind of like what you would expect. And sometimes you get values that are way off because you did like maybe multiplication instead of addition, something like that. Or another example of a logic error would be if you use the wrong variable name in a calculation. So you meant to use like the sum of something, but instead you use the average value instead. So you'll get a very different value, but that's not wrong. It doesn't create an error, and it's not a syntax error. So your program runs fine, but your data, your output is off. And so then you really have to go in and start kind of going through line by line to figure out where the error is. So that's what a logic error is, and they are by far the hardest to find. And that's where when you do your testing, you set up expected results for a specific input. And if you're not getting that, then you know, okay, I have an error here. This lets me know I have one, and then I need to go in and find it. All right. And we are now at this question. All right, here we go. Very good. Yes, the answer is B. So if we trace through this a little bit, again, you can write this in your booklet and check it later. All right, so we start out with degrees being 75, and 75 is not greater than 75. So we know that's false. And notice we're using ands and ors. So this is how they will test your knowledge of these logical operators, because with an and, remember that both sides, both operands have to be true for the and to be true. All right, for the overall statement or condition to be true. So degrees 75 is not greater than 75. So this gives us the value of false. And then we already know the whole thing is going to be false because with an and, again, both have to be true. And then our day is Sunday and not Friday. So we are comparing false and false. Now, occasionally I will get a student who thinks that, oh, if both sides are the same, then that makes it true. And that is incorrect. All right. Both sides have to be true for an and condition to be true. All right. So we know this one is false. So now we come down and we check our else if. And then we say, oh, is 75 greater than 65? Why, yes, it is. So we have a true right there. And we're using an or in this case. So with an or, only one, either side or both, have to be true for the entire condition to be true. So we already have a true. We know this is going to be true no matter what is the case here. And then, so we're going to execute display, wear a sweater. And just remember, anytime as soon as you hit a condition that is true, the rest of the conditions will not be evaluated. All right. It will skip over those as soon as it finds the first one that's true. So very good, wear a sweater. And as my kids used to always say, oh, we wear a sweater when mom is cold, not whether we are or not. All right, next question. All right, let's explain this one. All right, so the correct answer here is false. And here's my little section of code where I'm kind of working through the different options. All right, so here are our values. Red is true, green is false, blue is true. So we want to display the result of red and green. So we're using these logical operators again. So we are comparing true and false. All right, and we already know, we just discussed, when you have an and, both operands have to be true for it to be true. So red and green comes out to be false. So we've already eliminated two possibilities here. We know the correct answer is either going to be B or D. All right, then our next display statement is not green. So remember, the not statement just flips it. It flips a true to false or a false to true. So green is the value false right now. So not green would be true. All right, so now we have a false true, and they're both the same right there. So we got to go all the way to the last one to figure out which one is the correct answer. So this one is a compound statement. We have to evaluate this operation first, blue or not red, to get it down to a single value to then compare it with and green. So blue is true. So we have true or not red. So we know with an or, we only need to have at least one of those to be true, and that's our blue. So true or not true turns out to be true because we're using an or. So we're doing true and green. So green is false, so we're doing true and false. And as we know, not both of those are true, so we end up with false. So D is the correct answer. That gives us false, true, false. On to the next question. Let's give them a minute for this one because this one does have a little bit more reading and thinking through. All right, so let's talk about this one. So you have to kind of think about, all right, when doors are left open and 15 minutes have elapsed, then we're going to send an alert. So let's think about, how would we know when a door is open? So if we keep track with our counter, if it's open, 1, if it's closed, 2, open, 3, closed, 4, open, 5, closed, 6. And if you're looking for patterns, which I recommend you do, notice that every time it's open, it's 1, 3, 5, 7, or odd numbers. And every time it's closed, it's an even number. So that's why we're using our modulus math. And that's how you'll kind of see them test your understanding of the mod math and the mod function. So we take our counter, and then our first condition here, we're saying, oh, if we do modulus math, because remember that means you divide by whatever number you have here, and you get the remainder only. So if we divide count by 2, we're checking and the remainder is 0, we're looking to see if it's an even number. So if a number is even and the timer is greater than 15, it says display doors ajar. Well, we just figured out that's not the case. It's when the number is odd. So let's look, oops, here's the answer. Let's look at B, all right? And this one's different. We're doing mod 3. Well, let's see if this could work, all right? If count is 1 and we divide by 3, oh, it's not 0, so we don't display or, oh, notice we're also using an or. But what you need to think about here is the number 6, okay? 3 is a multiple of 6. So 6 mod 3 is also 0. So that's saying, oh, if it's 6, we're going to display door is ajar if time is greater than 15. And that's not the case. All right. It works for some of our cases, but not all of them. All right. Now we know this is the correct answer, but let's look at this. If you divide by 2 and you end up with a remainder of 1, that tests to see if you have an odd number. And we figured out, hey, when the door is open, we have an odd number. So we're checking to see, is the door open? And we have an odd number and time is greater than 15. And then we want to display door is ajar. And D, just to kind of go through it quickly, it's doing another different mod here with 4 instead of 3 or 2. And so let's see if it could work. All right, remember anytime you have a smaller number with modulus math first, and you're dividing by a larger number, for the remainder will always be that first number. So if we have 1, okay, it works. But if we have 3 mod 4 is 3 instead of 1. So it won't display door is ajar when it should. So that's why D does not work. All right, here's another question. All right, very good. Okay, and notice I put in here in bold, what is the largest decimal number equivalent that can be stored in 8 bits? And just a reminder, a bit is a single binary digit, and 8 bits make a byte, B-Y-T-E. And what I did is I created a table down here with the powers of 2. Remember, any number to the power 0 is 1. And then 2 to the first power is 2, 2 squared is 4. Notice each column doubles from the one prior because we're dealing with 2s. And so whenever we have the largest number that we can store here, we put all 1s in our table here. All right, now this is the largest binary number that can be stored here, but we're looking for the largest decimal number. And this is the kind of way that they'll check to see that you understand how to do this binary to decimal conversion and back and forth. So basically every field that we have a 1 in, we add those numbers together. So we're basically doing 1 times 128 plus 1 times 64 plus 1 times 32. But since you know 1 times any number is the number itself, we are just adding each of those fields that have a 1 in them together, and we get 255. A shortcut is to remember that anytime you have all 1s to the right of another column, it's 1 less than that column. So for example, 2 to the 8th would be 256. And so that would be 1 less, all 1s in these columns would be 1 less than 256, which is 255, which we calculated as well. All right, next question. All right, here we go. Very nice. All right, so this is a similar kind of question that you'll see. They'll have like a section here with missing code. What could replace missing code in the example here? And so in this case, we're looking for calculating the average. So we have our for each example here where we're adding each number in the list nums to the value sum, and then we're missing the actual calculation part, which you guys are probably all very familiar with. If we look at option A, if we had a variable count that counted each value in our list nums, this could work, but we don't, so that won't work. Item B is trying to divide our sum by the whole list, all the numbers in the list, and that just doesn't work. That's not possible. C is looking for, hey, remember that length value that we had, that length method we learned earlier, okay? It tells us how many elements are in our list and returns an integer. So if we divide our sum by this, and of course you would probably first have a condition to check to see if the length of your list is 0, because you don't want to divide by 0, but you could divide your sum by however many elements are in the list, and that calculates your average correctly. All right. There are certain common algorithms you have to know, and this is one of them, the average calculated, and the code to represent that is one of those that you're responsible for knowing. All right. Next question. All right. Here we go. So this one throws my students a little bit as well, which is kind of why I included it. So remember with procedures, we have our keyword procedure here, and then this is the name that we've given our procedure, and you have to call it exactly the way it's spelled. So the way you look at this is the only capital letter we have is the W. So we've already eliminated a couple of options. We only have B and C, which are correct. All right, the other two have a capital C, so you got to watch for that. Now, to distinguish between which one of these it is, let's look again and notice that our procedure has one parameter here. So we know that whenever we call this procedure, we have to pass it a value. And so the only option between B and C that does that is B. Now you don't know, blue team is a variable. You don't know what's stored in it, but it's most likely going to be the score since that's what the procedure is expecting. It should be a number in there. And it confuses my students because they say, oh, check when. Okay, they kind of ignore the fact that it's not spelled exactly the same because they think that, oh, 25 looks like a score to me. That's what I interpret it to be. So that must be what it is, but it's not. All right, look for the exact same spelling and then look for the number of parameters it's using. All right, next question. All right, let's look at this one. And this is one of those where I would definitely write it in your book. And I would not write out all the words. I would just write, or put the quotes or anything. I just did that for your benefit. I would, do G for grapes and an O for oranges and A for apples, that kind of thing. But go through each step. So we start out with grapes and oranges when we initialize our list named fruit. Then we append apples to the end. All right, here's apples at the end. We remove whatever is at index position 1. So grapes, they're gone. Now we only have oranges and apples left. And then we append berries to the end. So we have oranges, apples, and berries. Insert kiwi at index position 2. All right, so now we have oranges, kiwi. Notice apples got moved over 1. It did not get overwritten, and berries moves over 1. And then we start and we look at and we have insert bananas at index position 3. So now we have oranges, kiwi, bananas. Apples gets moved over again, berries gets moved over. And then we remove whatever is at index position 4. All right, and so now apples is gone, and these are the values in our list, and I put the index position here for each of these. And then we wanted to know what is at index position 3 at the end, and it is bananas. Now, something I really want to point out here, some programming languages don't start the index position at 1. But if you used that to, do your create project, now is the time to forget that after you've turned in your create project, because this exam uses index position for lists and strings starting at 1, not 0. All right. So always remember that with the questions on the exam. All right. Next.
We're cruising through. We're an hour in. So I don't know how much I know there was a bunch left you wanted to get to. Just want to throw that out there. We got about 29, 30 minutes left.
All right, we're in good shape. Thank you. All right, so for this question, what order should we put the lines of code in? All right, so if we're going to display an updated digital scoreboard, all right, then we probably want to do our display statement last. All right, so we can look at our possible answers, and line 1 is only last in B and D. So we've already eliminated 2 possibilities. And now you just have to think about, okay, if I want to update points 1, I have to have the value inputted in, and then I have to have it before I can calculate an updated score. And the same with points 2. I can't update score 2 until I have the values pointed in, input in for points 2. So just make sure that the other values to determine which one is the correct one will put whichever one you start with. In this case, it started with 2 for input, and then make sure that you are updating score 1 before, and then it has inputting the score for points 2 and then updating points 2. Make sure you don't have 1 and then trying to update score 2. All right, next question.
Sorry, guys, I'm not able to share this for some reason. Let me try again.
And while she's working on that, y'all just keep working on the question.
Do you see it now, Simone?
Yeah, for the remaining polls, I'm unable to launch, for the remaining questions, rather, I'm unable to launch the poll for some reason.
Is this the right one? Digital scoreboard?
Yeah, it's the right question and I can see it, but it says a poll has been shared in this meeting, which I'm not sure what that means. I've never had this issue before.
Okay.
But I've also, this is the most questions I've had, so I'm not sure if that has anything to do with it. But yeah, for some reason, I'm not able to launch any more questions.
That's all right. We will just work through them and talk them through. So This one has had roughly a minute, so let's go ahead and look at it. You will most likely see a question like this on the exam. All of the released exams have had something similar to this. And it's looking to make sure that you logically understand how to swap values, right? And so with this question, look very closely because notice it gives you the initial value and the value after swap. Value 2 is not changing at all. So you can already look at your options over here, and any answer that's trying to update the value for the variable value 2 isn't necessary. All right, so you can go ahead and eliminate C and D. So this is another one to write down in your text booklet because it's really easy to get yourself confused. And again, especially under a testing situation. And if you want to come back and check your results, you can just check your writing in your book instead of having to think it through again and save time. So we want after our code to have value 1 be the value of 42 and value 3 to be the value of 22. All right. So if we look at option A, we have a temporary variable. So you always need some type of temporary variable to hold on to one of those values so you don't overwrite it and lose it. So we set our temp variable to be whatever stored in value 1, which initially is 22, right? So far so good. We update value 3 to be the value of value 1. And so it now has 22. But as you can see, we have lost value 3's initial value of 42. So all of temp value 1 and value 3 are now all 22. So that didn't work. And let's just look at answer B. Again, temp 1 is value 1's value. We assign that and it's now 22. Then we assign the current value of value 3 to the variable value 1. Aha, this is working better. We assign 42 and it overwrites our 22 and we have 42 now for value 1. And then we assign the current value of temp to value 3, and it effectively swaps the values in value 1 and value 3. So definitely make sure you understand this algorithm and how it works because you will likely see it on the exam. All right, just a couple more practice questions here. All right, so let's look at this one. As hard as it is to believe that a 5-second video a 5-minute video could ever be smaller than a 5-second video, it is possible. And they're testing your knowledge of lossy versus lossless data compression here. So there are some really effective compression algorithms out there that, yes, can compress a 5-minute video to be smaller in size than a 5-second one. You don't always get the best result. It can look grainy, kind of blurry, but it can be done. I have done that before and it does work. All right, next question. All right, the poll's working again, but I was timing this one, so we're going to go ahead and move on with this one. All right, so this is kind of checking some of the information from that last category in the big ideas. All right, if somebody has a free online game, no, they don't need to have any of your personally identifiable information for you to be able to play the game. There's no idea what they're going to do with it, if they're going to try to sell it or use it for some other reason that they have no business sharing. So the answer is no. Even though you guys are probably a lot more comfortable sharing your personal information to get something for it, like access to a free game that a friend told you was very cool, than someone like I am. All right, so which diagram indicates how the internet is designed? All right, very good. Yes, this first one is centralized. Notice that everybody is connected to the central one. So if the central node goes down, everybody's out of business. If you look at B, this is like your typical bus structure. It's very old, but you'll still see it in use in places. But if this section of it gets broken, then these nodes are no longer connected and not able to communicate. C is correct because we have redundancy built in on purpose, and every node has more than one link to it. And then the only difference with D here is notice we have a couple of outlying links here that only have one connection. So they do not have the redundancy built in throughout this structure, and that's why it's not correct. All right, last question, I believe. All right, so this question is checking to see if you understand the concept of distributed or parallel processing. So it tells us that we have one data center that's gonna, with one computer processing all the data, and then we have another one that uses multiple computers. So that's the one doing the distributed or parallel processing. And so it's checking to see if you understand the concept of speed up, and that's what results from comparing the time from the sequential processing here and then the one with the parallel processing going on. And I put the calculation for speed up down here. I don't know that you'll necessarily have to calculate it, but you do need to understand the concept. But for example, the speed up in this case, say we had the first data center with one computer processed in 4 hours and the other data center that used multiple computers processed in 2 hours, then our speed up calculation is 4 divided by 2 or a factor of 2. So we sped up our, our processing by a factor of 2. So that's where that comes from. All right, so how are we doing on time, Bob?
We're at 4:42 Eastern, so we got about, what, 17, 18 minutes left?
All right. What I can do with this last section, because for everyone's information, there is an explore curricular requirement. And so your course instructor will make sure that you spend some time on this. There's a required amount of time to spend on these types of questions. And in the exam, there will be a scenario, and it usually has some type of graph or chart that goes along with it for you to look at and understand, analyze, and then 5 questions related to this scenario. All right. And in this case, they're going to be more tied in with innovation, privacy, security, storage, beneficial effects versus potential harmful effects. And they're all going to be right together within the exam. So what I can do here is just show you this question. All right. So this particular example has us showing with the flow chart here, we have the ramp meter lights to help regulate traffic going onto an entrance ramp to improve the flow of traffic, reduce traffic jams. There's a camera that records data at that location and transmits it to the city's data center. And then this flow chart says, all right, check the time of day. Is it a weekday and is it rush hour? And if it is, go ahead and turn on the ramp lights, have them working. Then if it's no, then it says, hey, look at the camera data. If this data is showing some number greater than whatever threshold you set, like there's too many cars on the ramp, then turn on the ramp lights. Otherwise, nope, don't turn them on or turn them off if they were, and go back up and check again. So that's what it's checking for. And I'll just show you this question so you can pause the video later if you want to and look at the question, and then here momentarily I will show you the answer. Oops, too far. There we go. All right, so it's looking at what kind of data cannot be captured at the entrance, at the ramp entrance. We already know we have the date and location of the actual meter, and then it's tracking the number of cars that pass through the entrance ramp each hour. We have no idea how many cars are on the highway, even though it may pick up some of that through the camera view. All right, here's another question. So you can pause the video here. And then the answer here, it says, what type of concern is most realistic? And you're going to have to look for questions that kind of say most, least, most likely, things like that. So in this case, what concern is most realistic is this privacy concern, because your car is being captured through the camera. It could capture part of your license tag. It could capture, the date and time where you're at a location. You may be able to identify whose car it is. You might not be able to determine who was actually driving it, but that is a risk to your privacy through the capture of that information. It's valid for a security concern. That's anybody who could update the data. So if the Department of Motor Vehicles could view the data, that's not going to be a concern. They probably have to do that as a factor of their job. Storage concern. Well, there you are collecting a high amount of data. You may not keep it all, or you may aggregate it for historical purposes, but there are plenty of server farms out there who are more than willing to store your data and process it for a fee. And then I just made up option D. Personal protection is not one of the options that we're looking at or is included in the course curriculum. That's your red herring. All right, here's another question. Pause the video if you want to take the time to answer it. All right, so if you're responsible for writing the code to activate the values, what data do you need? All right, so we already have the camera data, talked about that, but we kind of need to know typical traffic patterns for weekdays. And that's how you could set the initial values for the ramp light on and then start testing it with your code. The number of red and green cycles in an hour, not really of interest, not really helpful to determining what to set those for. It could be, that could vary as well, depending on time of day, day of week as well. And then again, pressure sensor data is not going to help you set those initial values. Those are more like real-time values. All right, question 4, pause. And here's another one of these questions, least likely potential benefit. Okay, it is very likely people will change their routes. Okay, I'm definitely one of those. I will, go somewhere else where it's less congested to try to get on the highway. Fewer accidents, very likely, because you have safer merging onto the highway. Very possible because you have fewer traffic jams, hopefully, as a result, so you have better fuel consumption. You can't really tell if the air quality, if it changes, is related to these ramp meters. So, hey, it'd be great if it was, but you couldn't necessarily determine that that was the cause of it. So that's why it's the least likely potential benefit as a result of these. And then here's our last question related to this Explore curricular requirement. Pause the video if you want. And then here's the correct answer. So this is one of those where you're looking at like the side entrance, so that make sure you're not creating a traffic jam farther up the chain there onto the city streets. But somewhere in there that you're probably going to see an answer that includes like just sensors and data, or sensors and cameras. Earlier, we talked about sensor data and camera data. And so this is what you'll see. The sensors and cameras are devices. And so they're going to have somewhere in there a question that tries to make sure that you understand the difference between the device that captures the data and the data itself. All right. So it doesn't really help to know the average number of vehicles that fit on the ramp to know if you're backing up traffic onto the side streets. But you need to know some type of information to know when they are backed up, whether it's camera data, whether it's some kind of sensor of another type. All right. That is it for all of our questions and answers. Anybody have any questions at the moment in the Q&A section, Bob? We good?
I don't see any here.
Okay. Well, then this last few minutes before I turn it back over to Bob, just a few study recommendations. All right. Here are the percentages of the questions that will be on the exam. Okay, notice it is a bit of a range. I will tell you, teachers, that I usually, even though it's a higher percentage here, I usually save this section for last. So if we're running out of time, we spend less time on it. Simply because some of this is so new to my students, they need a little extra time to process it. And they've proven themselves to be a little more adept at analyzing these questions. Okay, they're a little more intuitive to them to be able to either sort through the answers, eliminate a couple of the options, and then select the correct ones. Then I'm basing this on like test questions that we do in class, whether it's from prior exams or questions that I've come up with. So that's why we do it that way, just FYI. All right, so remember, 30% of your scores due and done May 1st at 11:59 p.m. Eastern time. All right, then there are 70 multiple choice questions on the exam, and it counts for 70%. So hey, you get 1 point for each question. Basically, each question is 1% of that score. There is no penalty for wrong answer, so please answer everything. Even if you're at the last minute and you're just checking anything, you have nothing to lose. So make sure everything is filled in. The exam is 2 hours long because you don't have those FRQs, right? You've already turned that in through the create performance task. It's only 2 hours long and only multiple choice questions. So you roughly have, a minute and a little over a minute and a half for each question. You do not get a break in between, all right? No breaks. And the exam is Monday, May 8th at noon. So for your exam preparation, take the diagnostic exam now so you can identify any areas you need to focus on and review those areas to fill in any knowledge gaps. Then take practice exam 1 2 weeks before the exam. And again, you still have plenty of time to review concepts, fill in those weaker areas. Take practice exam 2 a week before the exam, and then the night before, get a good night's sleep. All right, you will probably remember more than you think you do, and cramming will not help. Okay, get everything ready, pull together that day. The next day, make sure it's at noon, so eat a good breakfast or a late breakfast, early lunch. Have your number 2 pencils. You can't have a watch that connects to the internet, but you can have a watch. You can't have a calculator, no scratch paper, no cell phone. Remember, put things in the test booklet. Okay, you can kind of help reason through and get to an answer. Eliminate possibilities and then guess if you have to. But remember, no penalty for wrong answers. And the exam reference guide. You will have a copy of the exam reference guide during the exam. So you can look up the format of things like the methods you have to know with lists, the format of the if statement, the format of the loops. So you have a little guide there, a little crutch there, a quick reference guide to help you through. Don't rely on it though. Don't assume you don't have to study because you get that. All right, and here are our days. Days left until the create project is due, and then days left until the actual exam. You have got this. You are going to be ready. And with that, I will turn it back over to Bob.
Thanks, Julie. That was terrific. So we've got a few minutes left. I just wanted to quickly introduce everybody to the digital course that accompanies these 5 steps materials. Quick note is that everything that Julie just shared with you, all of those practice questions and the explanations, they're all in our 5 steps guide. If you've got roughly 2 months to go, those 5 steps to a 5 resources are really good test prep tools that you can use between now and the test date. If you're a teacher, if you're a student, anyone listening to the recording, everything that's been discussed here is available in there. So please go pick that up. And real quickly, this is something that's an online course that's available with our 5 steps resources. By attending this or watching the recording, you're given access to it. So if you're with us now and you want to take a quick screenshot, take a picture with your phone of that URL and the access code. If you're listening to the recording, just pause it for a second. And it's really easy to get in. I've already got it up. So if
like me to
Julie,
stop
if you
sharing?
can stop sharing and I'll begin.
There you go.
I'm not going to walk you through. There we go. Can you see that, Julie? Can you see my screen?
I can, yes.
Okay. I won't walk you through the login. It's really simple. It'll ask you for your name and an email address. We're not going to spam you. You're not going to get anything from us except for one email verifying that you've joined. The first thing you'll see is a calendar. Like Julie just said, this test is being given May 8th. I've already entered that May 8th is my test date, and that leaves me 69 days to study between now and then. When I come in tomorrow, that'll be down to 68. And if I come in a week from now, it'll update accordingly. So it's a really robust, self-guided study tool that you can use that's going to update with you and stay with you all the way through the day you take the test. This dashboard is just a real quick sort of shows you that I've only done 8% of my work in here. But I did go through a bunch of it today while Julie was talking, so I'm above my knowledge goal of the day, quite significantly there. Once you get in here, if I log out and come back in, it'll show me what my average score is, my average scores on the test, my strengths and weaknesses. It's a really cool tool that will update automatically once you get in, once you come back in. Quick note, if you're using it on your desktop, and then you have to jump on the bus and get to school and you log in and do a couple of questions on your phone, it's going to read you, it's going to update automatically. It'll pick up where you left off, no matter what device you're using. So real quickly, it's you've got the study plan, which is just basically everything that's in the book, available online. You've got a game center, which is a bunch of mostly some pretty simple flashcard based games. But, you know, you want to study for computer science principles on the bus, as I said earlier, or on your phone. There's a couple of fun gamified ways to get through it. A small forum for discussions. What you'll see in here is sometimes students talking back and forth to each other. Hey, did you think that number 19 on test 2 was a little confusing? Back and forth. So that is a pretty interesting resource if you get a chance to use it. And the meat of it is down here. So all the lessons you'll go through and it's all broken down. Everything you need that's based on our book again is broken down into individual lessons. Julie has set up her curriculum or her 5 steps guide through the 5 to reflect the 5 big ideas. 1, 2, 3, 4, and 5. Earlier today, I flew through big ideas 3, 4, and 5. And as I went through, I quickly graded myself. I read about algorithms and programming. That's pretty basic stuff. I'm going to rate myself as high and go through. So the things that you know well that you don't need to come back to, you can rate yourself as high. Other stuff, I struggled a little bit with combining rhythms, and lists. I rated myself low. So the next time I come back in, if it's 2 weeks from now, I go in and I can see where I self-graded myself as low or medium, and I might want to jump back in and review. Some real quick flashcards. 1 click, and you see the definition. Again, it's self-guided, so did I get it right? No, kinda, or yes. Grade yourself as no or kinda. You'll see them again. If you get it right, you won't see that one again. Algorithm. There's 123 for this course, which is a decent amount. Again, for study on the go, anything you want to do, they're here. You've got everything, a lot of practice questions, again, broken down by the 5 big ideas. Tons of resources here. You've got 36 questions in algorithms and programming. So there's that. That's a really robust section. And the most important thing, and Julie was just recommending that everyone take a diagnostic test. You've got access here to 3 full-length exams. The diagnostic and then 2 full-length exams. I'm sure Julie would agree, and we hear a lot from our authors and educators, that it is really important to time yourself on at least once going through before test date. That way you know what your pacing is like. It gives you an idea of what you're going to see and the types of questions you'll see. And you got that 70 minutes or 70 questions in how many minutes is it, Julie?
You have 2 hours, so
hours?
120 minutes. Mhm.
Just about 2 hours. So there's that it's and I think that's probably the most useful resources for you listening in today. So that's it. I think we're just about at 5 o'clock. Let's see if there's anything else. Oh, thank you, Anya. Anya posted in the chat reposted the code and the URL. I really would recommend, that was just a real cursory look. Jot that down, take the URL and the code and go back and share it. Share it with your friends, your colleagues, your students, the kids in your class. It's a really good review tool between now and the test date. I didn't do it justice here in a couple minutes that I had, but spend some time in there. It's really going to help you as you head into the test. That's about it. We're 1 minute over. Any final thoughts, Julie?
Nope, I just want to wish everybody good luck.
Terrific. That was really valuable, Julie. I think it was a terrific resource. You did a lot in a short amount of time. So thank you very much for your cooperation and your participation in all the 5-step stuff that we do.
My pleasure. Thank you.
And with that, I guess we'll say good luck and we'll be signing off. Thank you.
All right.
Take care, Julie.